Hey guys, so welcome back. We're continuing on double integration with non-rectangular regions. The question that we have today says sketch the region whose area is represented by the integral from 0 to 2, y squared to 4 of dx dy. Then we want to write a corresponding vertically simple integral to find the same area. So first of all, before we do that, let's break down really what this is actually asking us to do because we want to graph it. So right now you see that we have a 0 and we have a 2. So over here, I want to make sure that we understand that this is going to be y, right? So we actually have the equation of y equals 2 and y equals 0. So then over here, we're going to graph, well, what does y equals 2 and y equals 0 look like, right? So y equals 2 is going to be 1, 2. So it's going to be right there on that line. And then the x-axis. So this is the region that we're integrating over, right? Because y dy is on the outside. And then what's more important and easier for us to understand here is that, well, let's look at what the functions are going to be. So we have ourselves a 4 and we have ourselves a y squared. Well, this is in terms of x. So we have a y squared equaling x and an x equaling 4. So we can remember that we can rewrite this function as y is equal to the positive and the negative square root of x, right? So we want to draft that. Since we're looking at this problem, and that is absolutely horrible, so I'm going to really quickly try to redraw that again. That's a little bit better. So I'm only drawing the positive part of this because, again, we're only region from 0 to 2. And so we have this, and then we have the line x equals 4. So that means, guys, that we're going to look at the highlighting of this region right here. So this is what we want to highlight. I don't know why it always does this. So there, and it keeps doing it. Anyways, you get the idea. All right, there's our region. And I'm done with this. So I should have done this off the video, but all right, okay. Anyways, that's our region. I'm just gonna leave it as is. So this is what we are starting with. All right, so this is our sketch region. So this is what we've just done. So we've already sketched the region that we're trying to find out, although my color system is not doing well here. So another thing they want us to do here is we wanted to sketch this thing in another way. So what they want us to do is we want to do the same thing, but now instead of dx dy, we want to do dy dx. So we want our constants for x to be the outside, and we want our functions with respect to y equals right here, right? So I hope that makes sense. So let's do that. Well, the first thing is that our bounds are x equals 0 and x equals 4. So we're going to go ahead and replace our functions from bottom to top, which is what the 0 and 2 are, to a 0 and 4 here. All right. And since now so that's going to take care of our x values, right? That's going to be the bounds from our 0 to 4. So now y, what we want is we want the equations for the function on the top and the function on the bottom. Well, the function on the bottom is clearly going to be y equals 0. So that's going to go right here. Because remember, this is y equals 0, just like over here, that function was x squared equals 1. And then up here, we want the function that's this. Well, that's going to be y equals the square root of x. So we're going to replace the upper bound with the square root of x. And I need to write that look a little bit better for us right here. So this is what they want. So what is written right here is the answer. So now we have write a corresponding vertically simple integration of the same area. So if you integrate this or this, you will get the same value for this. All right, so that's really all it is. It's just making sure you guys can set stuff up, understand what the integrand is actually asking you to do. So what I'd like for you guys to do for me now is to try example number 3 right here. So remember, it's just asking to set up our region of x minus or 3 minus x dA, where d is the region bounded by the positive x-axis and the graphs of y equals the square root of 2x and y equals negative 6 minus x. So take a second, pause the video, and see if you can sketch these two functions and see what region you want to draw here. And we're going to go ahead and talk about it here in 1 second. So take a second, pause the video, and try it. All right, guys, so I've done a little bit of stuff here. I want to continue on talking about the problem itself. So a couple things that I did was go ahead and sketch the two graphs. So y equals the square root of 2x starts at 0, and it still is a kind of a square root curve. So again, without a graphing calculator, you can get the idea of what this looks like. And then this is the square root of x. However, it's starting at 6. We have shifted to the 6, but because x is negative, we're actually going in the left direction. So this is what our curves look like. So the intersection is right here. So a couple of things that I have noticed in the problem is that if I want to keep it in terms of y equals, the reason why I went ahead and wrote it in terms of x is because if I were to graph a function and keep it in terms of y equals, that means that my rectangles have to be in terms of x. And if you guys look at what's going on here, this is not ideal because on this side, the top curve is actually the brown curve. And then in this side, the top curve is going to be the pink side. So if you did that, you'd have to set up two different intervals. However, if we make our rectangles in terms of y, right, then our right-hand curve is always the pink curve, and our left-hand curve is actually going to be the brown curve. So we want this to be in terms of y, which means that our bounds need to also be in terms of y. So this means that we want y equals a constant here, and we want x equals a function here. All right, because again, we want everything in terms of y. So our bounds are going to be 0 to 2, because again, it's the bottom and the top. And then the reason that we're doing it this way is because now our right curve minus our left curve, right? Again, based on what we did back in AB and BC calculus, it's always right minus left, but that's going to be our top curve. So remember, the top curve is going to be the right-hand bound. So we're going to do 6 minus y squared. 6 minus y squared. All right, again, remember, this is always going to be the right curve, the one on the right-hand side. And then the left curve is going to be our lower bound, again, with if everything's in terms of y equals. So that's going to be 1/2 y squared. And so we're going to go ahead and add the y to our integral, to x to our integral, because this is in terms of x, and then we're going to do dy. And so that's our setting up problem for this. All right, so this is where we set the problem up. So I want to make sure that I reiterate to you guys the reason why we do it in terms of this, right? This is a region 2 graph because we don't want to go and do two different intervals. So I hope this makes sense to you guys. We're going to come back in one more video of this lesson where we will have to set up two integrals. And so we will do that in our last video. So thanks, guys, and I'll see you in the next video.